Question number 3. It states the boxes on the left contain names of the some sources of energy. The boxes on the right contain properties of some sources of energy. Draw two straight lines from each box on the left to the two boxes on the right, which describes that source of energy, right? Beta, so we know that solar energy, is it a renewable or not renewable? Beta, solar energy, is it renewable or not renewable?
Sir, renewable.
Shabash. And beta, is it polluting or non-polluting?
Sir, non-polluting.
Shabash. So now natural gas, we know it's not renewable and beta it's polluting, right? So this is what we had to do in this question. Next beta, coal-fired power stations are polluting, right? State an advantage of using coal as a source of energy. So beta, you remember when we discussed, I told you there are two advantages of non-renewable energy sources. And you know what were those? They are readily available and they are high energy density, right? So we have to tell here, state an advantage of using coal as a source of energy, right? So beta, what advantage is what is the advantage of using coal as a source of energy? Beta, it's widely available, right? Widely available, or you can say readily available, right beta? Beta, got it or not?
Got it, sir.
Yes, sir.
Beta, coal-fired power station generates electricity at night when it is not needed. Some of this energy is stored by pumping water up to a mountain lake. When there is a high demand for electricity, the water is allowed to flow back through turbines to generate electricity. On one occasion, 2.05 times 10 to the power 8 kilogram water is pumped up through a vertical height of 500 meter. Calculate the weight of water. So beta, we know that W is equal to mg. Mass of the water is 2.05 times 10 to the power 8. Value of G is 10. So beta, if you do this, you'll get 2.05 times 10 to the power 9 newtons. Okay beta?
Can we use 9.8?
जी beta?
When exactly can we use 9.8?
Beta, its value is 9.8, but I told you for simplicity in calculation we use 10. Okay? And even beta, if so you can use 10 unless it is mentioned. Means for Earth you will use 10. Okay? Gravitational field strength of Earth. Beta, calculate the gravitational potential energy gained by water. So beta, gravitational potential energy gained by water. Gravitational potential energy gained. What will be the beta formula? mgh. Now beta, what is the mass of the water? 2.05 times 10 to the power 8 times value of G is 10. And beta, height, what is the height? Pumped up through a vertical height of 500 meters, right? So beta, 500 meters. Now beta, if you multiply this, what do you get?
There we get 1.025 times 10 raised to the power 12.
1.025 times 10 to the power
12.
12. Okay, so it's 1.0 1.025 or 1.25?
1.025.
1.025. Okay, 1.025 times 10 to the power 12 joule. Okay, better tell me, is it 1.025 or there is something after 5?
Sir, it's 1.025.
Okay, better I'm asking because often when you round off you make mistake in rounding off. So that's why I was just checking to make sure. Now beta, uh, the electrical energy used to pump the water up to the mountain lake is 1.2 times 10 to the power 12 joule. Only 6.2 times 10 to the power 11 joule of electrical energy is generated when the water is released. Calculate the efficiency of this energy storage scheme. So beta, efficiency, see what are we given? We are given here energy. So beta, what will be the formula for efficiency? G.
Energy in over energy out multiplied by 100%.
Shabash. So beta, what is the energy input?
Sir, it's 1.2 times 10 raised to power 12.
Beta, it's not energy in over energy out. First of all, you told me the formula wrong. It's energy out over energy in. Output energy over total energy input. What happened, beta? How many times we did that formula? Energy output divided by energy in. Right or wrong? Now will you remember that it's always output over input? जी बेटा जी बेटा
Yes, sir. Yes, sir.
Okay. Now beta, so what is the energy output?
Sir, the energy output is 1.2 to the power of 12, sir.
Beta, look, the electrical
Oh, sir,
energy
actually, 6.2 to the power of 10 to the power of 11.
6.2 times 10 to the power 11.
11 joules.
Energy input
Sir, 1.2 to the power of 10 to the power of 12. So
times.
multiplied by 100%, sir.
Okay, so beta,
So, sir, that will
when
be
you solve this, what do you get? जी बेटा
Answer is 51.6 or
51
51.7.
51.7. I guess the answer is 51.6666, something like that, right?
Yes, sir.
So you can write, if you round it to like three significant figures, 51.7%, or if you want to write the answer in two significant figures, you can write 52%. Okay, beta?
sir, after 6 sixes, there's 7, sir.
Yes, so beta, if there is 666, so if you want to write till three significant figure or one decimal place, so you can write 7,
Okay,
right?
sir. Yes, sir. 51.67.
Got it or not, beta? Done?
Yes, sir.
Yes, sir, done.
Next question, beta. Beta, on day with no wind, a fountain in Switzerland propels 30,000 kilogram of water per minute. 30,000 kilogram of water per minute to a height of 140 meter. Okay. Calculate the power used in raising the water. Power used in raising the water. So beta, what is power equal to? Power is equal to, Shabash beta,
Work done divided by time.
So this
work
is
done divided by
work done by
time
time.
taken, or energy transferred divided by time taken, right? Fine. Now beta, what is the work done in raising the water? See beta here, beta, it's very important to remember this, understand this, and remember this, right? Beta, we know work done is equal to, okay, let me explain it here. Work done is equal to, work is equal to force, distance, force times Shabash beta.
Distance.
Distance moved in the direction of.
Yes.
Distance moved in the direction of. In the direction of force, right? Right or wrong, beta? This is the work now. Yes or no, beta?
Yes, sir.
Yes, sir.
And now, beta, you remember we have discussed, beta, when work is done on an object in lifting it against the gravity, then in that case the force needed to do work is equal to the weight of the object. Right or wrong? Right or wrong, beta?
Right, sir.
So here the water is being propelled upwards. So in that case, the work would be weight, and the distance moved in the direction of force is basically height. So beta, the work can also be, let's say, so when work is done in lifting an object against the gravity, so basically work is weight times height, right? So beta, if you know the weight of the object which is lifted against the gravity, you use this formula. If you do not know the weight, you know the mass, then beta, we know that how can we calculate weight from mass? We know the weight is equal to m times g. Okay, and height, we use h for height. So beta, simple. When work is done on an object in lifting it against the gravity, so work is equal to weight times height. And if you know the mass, if you do not know the weight, then it is mgh. Okay, if you know the weight, you can use this formula, weight times height. If you know mass, it is mgh. Got it or not?
Got it, sir.
So beta, here what will be the work done? It will be equal to mgh, because we are given the mass, right? Propels 30,000 kilogram of the water. If we would know the weight, we will use this weight times height thing. Okay, so power is equal to mgh divided by time. Right or wrong, beta? Ji beta, got it or not?
Got it, sir.
Now beta, what is the mass of the water that is propelled? It's 30,000 kg. Value of g is 10.
Height is
H
140 meter.
140. Time is beta what?
1 minute.
1 minute means 60
Six.
seconds. Now beta, you simplify this, see what answer do you get? Ji beta.
Sir, 700,000.
700,000 watts, right? Or beta, you can write in such standard form 7.0 times 10 to the power 5 watts. Got it, beta?
Yes.
Okay, next beta, the efficiency of the pump which operates the fountain is 70%. Here we are given the efficiency, right? Calculate the power supplied to the pump. Power supplied to the pump, it means what they are talking about?
Power.
So power
Which
is
power?
the
Input
amount of
power or
power
output
needed
power?
to
Input power.
input power.
Input. So power input is, we have to find. We are given the efficiency, right? So beta, we know the formula that efficiency is equal to what?
Energy out over energy in.
Beta, here, or it is also
Power input or power output.
Power P out over P in times 100.
shabash. Beta, it's always output, not input over output. It's always output over input. So efficiency is equal to power output, P out over power input times 100%, right? Right or no? So beta, here we have to calculate power input, right beta? So beta, P in will be equal to what? P in will be equal to P out, power output over efficiency, right? Right or wrong? Right or wrong, beta?
Right, sir.
I just
Right, sir.
rearrange this equation, right? Right, beta? And then beta 100%. Then beta we substitute the values. What is the value of power output?
700,000.
700,000 divided by what is the value? What is the efficiency?
70%.
70%, right? Multiplied by 100%, right? So beta, consider that this percent sign cancel this percent, right? Because percent means divided by 100. You divide this by 100 and divide numerator by 100, divide denominator by 100, so it will make no change, right? Those hundreds will cancel out with each other, right or wrong? Then what you left with? You are left with 700,000 times 100 divided by 70. So beta, if you do this, what do you get?
Sir, we get
1 million
1
watts.
million.
1 million watts, right? Or if you want to write in standard form, 1.0 times 10 to the power 6 watts. Okay, clear beta?
Yes, sir, clear.
Next beta, the question is, on another day a horizontal wind is blowing, the water does not rise vertically. Explain why the water still rises to a height of 140 meters. Beta, what it means? So when there is no wind, the water rises vertically like this, right? Now if there is a wind, due to the wind water does not rise vertically, obviously it is like it rises something like this due to the wind, if that is the direction of the wind, right? Now beta, they say it does not rise vertically, but beta it still rises the same height. Okay, the same height, 140 meter. Why? Ji beta. Beta,
Sir,
so
the
first,
the direction is changed, but sir, the
yes,
energy output is not. So, sir,
Shabash. So
it wouldn't
beta,
affect the height.
basically what makes the water go up? There is a vertical force. Basically the pump pushes the water, okay, upwards, and pump exerts an upward vertical force on the water, right? Right or wrong?
Yes, sir, unless if there was a downward force.
Yes. So basically vertical force is not changed, right or wrong? So this is horizontal
Yes,
wind.
sir.
So horizontal wind has no effect on the potential energy gained, or you can say the vertical force on the water, or you can say the same upward vertical force acts on the water, right? So the same upward force acts on the water, right? So that's why it still gets the same, still gains the same potential energy and same height. Got it or not? Ji beta?
Yes, sir, got it, sir.
Yes, sir,
Good.
got it.
Now beta, next is figure 3.1 shows a water turbine that is generating electricity in a small tidal energy scheme. Okay beta, you remember tidal, so this is sea here, and this is reservoir here, or you can say tidal basin. Okay, now beta, what happens when the tides are high? Water level rises here, and beta it moves. As it moves, it turns the turbine, right, which is drives generator and electricity is generated. Clear? Water moves this way, right? Now beta, at a high tide, 1.0 times 10 to the 1.0 meter cubic, or 1.0 meter cube of seawater of density 1030 kilogram per cubic meter flows through a turbine every second. Calculate the loss of gravitational potential energy when 1 cubic meter of sea water falls through a vertical distance of 3 meter. So beta, we know that gravitational potential energy lost is equal to mgh, right? So beta, loss of gravitational potential energy when 1 cubic meter of sea water falls through vertical distance of 3 meter, right? So beta, what is the mass of the water that falls through vertical distance of 3 meter, right?
1030.
Very good, shabash beta. Since we have to basically extract that information from this, because density of the water is 1030 kilogram per cubic meter, it means every 1 cubic meter volume of water contains 1030 kilogram of water, right? I don't know. It says 1 cubic meters of sea water falls. It means what is the mass of the water falls? 1030. Value of G 10, height 3. So beta, what answer do you get?
Sir, 30,900.
G. So 30,900.
900 kilo. Yeah, say
No,
that.
not kilo, beta. Only joules.
Oh, yes, sir, joules. I was about to say
30,900
joules.
Okay. Now, beta, assume that your answer to A is the energy lost per second by the seawater. Now, beta, leave this question. Okay. Actually, when I included this, I didn't realize basically this is, here, how would you find power? By the way, you have studied about it. In grade 7, you studied power is also equal to VI, right or wrong? So we are given voltage, we are given current, but you can leave it. So just leave that part. Okay. Right or wrong? Next is at low tide, the sea water level is lower than the water level in the tidal basin. State the direction of the flow of water through the turbine. Jibit. When there is low tide, what is the direction of the water flow?
Sir, it's closer to the
At
generator.
low tide, Jibita?
More to the generator than water, sir.
No. Beta, this is the sea water level at low tide. This water level in the sea is lower than the water level in the basin, right?
Yes, sir.
So then in what direction the water flows?
So the opposite.
More towards the left side.
Beta, so you don't just say left side, from
On the opposite
tidal
side.
basin to
Yes. To sea water level.
sea, right? From basin to
Sea.
from basin to sea. Okay. Now, beta, suggest an essential feature of turbine and generator for electricity to be generated at low tide. Now, beta, the basic essential design feature would be that when water flows in the opposite direction as well, right? When water at low tide, water flows.
So the generator also works inversely.
Shabash, mean it is designed so that it generates electricity in both ways, or the turbine turns means both ways. So when the water flows, now the turbine also turns, but in the opposite direction, right? So beta, the essential design feature is that rotation. It allows a rotation in both direction, right, beta?
Yes,
Right or wrong? So beta, turbine design. Design allows rotation in both directions. Okay, beta. So beta, actually there is one more question. Okay, beta, do that question yourself. I have shared this worksheet with you already, and beta, so do that question.